Alright guys, welcome to this page of the notes, and what we're going to do here is take a look at how you divide when you have nth degree radicals and it's in a fraction form, and we actually did this before, or we used a very similar technique back in chapter 4. It was actually section 4 of chapter 4 when we began to look at imaginary numbers. Or complex numbers, and I asked you to do division with complex numbers. It turned out that division of complex numbers was simply multiplication by the complex conjugate, which just simply meant you change the sign of the complex number and multiply top and bottom by that. We're going to use the exact same principle here when doing division of nth degree radicals. So what you're going to do is the binomial conjugates. If you're given a square root of b plus c square root of d, the conjugate would be a square root of b minus c square root of d, or vice versa. If you're given a square root of b minus c square root of d, the conjugate would be a square root of b plus, right? You just change the sign, and then what we'll do is we'll multiply top and bottom by the conjugate. All right, so it works almost exactly the same way as it did back in chapter 4, section 4 with complex numbers, except now you don't have i's running around all over the place. You have radicals instead. So let's go ahead and see how this is going to work doing this first example problem. So like I said, because I have division, we're going to go ahead and multiply by the conjugate. Top and bottom gets multiplied by the conjugate of the denominator. And you should remember that from dividing complex numbers. It's always going to be the conjugate of the denominator. So here we go. Let's go ahead and do that. Since it's 5 plus the square root of 3, we'll multiply top and bottom by 5 minus the square root of 3. So 5 minus the square root of 3, 5 minus the square root of 3. And again, just like with complex numbers, binomial, 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 it's foiling, right? You're going to FOIL this stuff out. So here we go. 1 times 5, well, that's a 5. 1 times the negative square root of 3 is going to be minus the square root of 3. Then I'm going to have negative square root of 3 times 5, which would be minus 5 square roots of 3. And then negative square root of 3 times the negative square root of 3. Well, negative times negative makes it positive. They're both square roots, so that means I multiply the 3's together and I wind up with plus the square root of 9, which turns out to be a perfect square. Awesome. All over. Here we go. In the bottom, now if you guys remember, same thing's going to happen here. We multiplied by the complex conjugate back in chapter 4, section 4, and we did that because the middle, when you FOIL, the middle terms dropped out. Same thing is going to happen here. I'll show you in the first one, and then the next ones we'll just skip it, knowing those middle terms will drop out. Here's what I mean. 5 times 5, well, that's 25. Then you're going to wind up with 5 times the negative square root of 3, which would be negative 5 square roots of 3. But then you're going to have square root of 3 times 5, which would be a positive 5 square roots of 3, and sure enough, those guys cancel each other out. Minus 5 square roots of 3 plus 5 square roots of 3. They go away. They're always going to go away. If they don't go away, you done goofed. Go back and figure out where you messed up. Square root of 3, negative square root of 3, that's going to be minus the square root of 9. Fantastic. Let's simplify this guy a little bit. In the bottom, those guys canceled. Square root of 9 is 3, so 25 minus 3. In the top, square root of 9 is a 3. So here we go. Let's write this stuff out. That's a 5. These are like terms. Square root of 3, square root of 3. The indexes are the same. The radicands are the same. So negative square root of 3, negative 5. So I wind up with negative 6 square roots of 3. And again, like we said, the square root of 9 is a 3. 25. And the square root of 9 is a 3. So minus 3. And I think we're going to get it in one last step. 5 plus 3 is going to be 8 minus 6 square roots of 3 all over 25 minus 3 is going to be a 22. Oh, hold up. Nope, I didn't get it in one last step. Check this out. 8, 6, and 22 all have something in common. They're all divisible by 2. Make sure you do that. 8 divided by 2 is going to be a 4. 6 divided by 2 is going to be a 3. And 22 divided by 3, or 22 divided by 2 is going to be an 11. So that is going to be in your most simplified form where you've pulled out your GCF. Hopefully that brings back some memories of what we did back in Chapter 4, Section 4 when dividing complex numbers by multiplying top and bottom by the complex conjugate. It works almost the exact same way. Really, the only difference is instead of having i's kind of running around all over the place, you've just got radicals in there. So let's do another one just to make sure you guys have got it. Here we go. We're going to multiply top and bottom by the conjugate of the denominator. Since it's 5 minus the square root of 2, we'll do 5 plus the square root of 2. All right, we need to FOIL this guy out. 4 times 5, that's going to be a 20. Ooh, hold up, that's not a very good 0. There we go. Then I'm going to have plus 4 square roots of 2 plus 5 square roots of 2 plus the square root of 4, because square root of 2 times the square root of 2, multiply the 2's together. You guys got it. We saw in the previous one, when I FOIL the bottom, the middle terms are going to drop out. They always should, so just skip it. 5 times 5, that's going to be a 25. Square root of 2, square root of 2, it's going to be negative, and you're going to wind up with the square root of 4. So minus square root of 4. Here we go. Square root of 4 is a 2. 20 plus 2 would be a 22. 4 and 5 is going to be a 9, so that would be plus 9 square roots of 2 all over 25. Square root of 4 is 2. 25 minus 2 would be a 23. And then check it. 22, 9, and 23. Do they have anything in common? They don't. So that's going to be your simplified form. Hey, one more. Let's do this one. We can knock it out real fast. These are pretty simple. Multiply top and bottom by the conjugate of the denominator. Since it's a 6 plus the square root of 5, we'll do 6 minus. All right, here we go. 3 times 6 is going to be an 18 minus 3 square roots of 5. Negative 2 times the 6 is going to be a minus 12 square roots of 5. And then we're going to have minus, minus, so those cancel each other out. It's going to be a 2 square roots of 25. So plus 2 square roots of 25. In the denominator, the middle terms will cancel each other out. 6 times 6 is going to be 36. The middle guys cancel each other out. Square root of 5 minus square root of 5, so it'll be minus square root of 25. All right, let's see what happens here. The square root of 25 is 5, and 2 times 5 would be 10. So we're going to have 18 plus 10, which should be 28. Then I have a negative 3 and a negative 12, so that's going to be a minus 15 square roots of 5. In the bottom, square root of 25 is 5. 36 minus 5 would be a 31. Check to see if there's a GCF, which I don't think there is. 28, 15, 31. There's nothing I can pull out of all of those. So that is going to be your answer in simplified form. You don't have a GCF that you guys can pull out. All right, so that takes care of our 2 objectives. We did 2 things in this section that are both very important. First, we looked at simplifying radicals by rationalizing the denominator. That's getting radicals out of the denominator and moving them to the top. A very, very important skill to have when it comes to simplifying radicals. So make sure you spend some time working on that one. If in a homework assignment, just get some practice. And then we looked at operations with radicals, adding, subtracting, multiplying, and dividing. Again, nothing terribly complicated, but just make sure you get some practice with them. That takes care of everything for this set of videos here in Chapter 6, Section 5. Thanks so much for joining me. I really had a great time, and I'll see you guys next time.